Hello everyone. Today we will study force on a current carrying conductor when placed in a region of magnetic field. We know moving charges experiences a force due to magnetic field. Magnetic fields create force in the conductor due to which the free electron in the conductor get drifted along the length of the conductor, and when these electrons which get drifted, they experience a force. Today we derive an expression for that force which is experienced by these free electrons in a conductor when that conductor is placed in a region of magnetic field. To derive that expression, let us consider a conductor which is placed in a region of magnetic field. We have seen here in the diagram crosses. These crosses, they show the magnetic field is perpendicular to that screen. The magnetic field is perpendicular to the screen, or this is the conductor. L be the length of the conductor, and the angle between magnetic field and length of the conductor is 90 degrees. And the force experienced by the free electron within the conductor, that is also 90 degree, mean the velocity with which the electron they get drifted, the force which is experienced by these electron, and the magnetic field, these three components, they are mutually perpendicular to each other. Again, I repeat, that is cross, they represent the magnetic field perpendicular to the screen. Free electron get drifted along the length, and the force experienced by these electrons is also be perpendicular to the V as well as magnetic field V. To derive an expression, let us consider length of the conductor is L, area of cross section of the conductor is A, capital A, number of electrons per unit length in the conductor is equal to small n, charge on an electron is small q, drift velocity small v, and magnitude of magnetic field is capital V. As the conductor is placed in the magnetic field, all the electrons of the conductor will experience individual force. Mean in a free conductor, in a conductor there are large number of free electrons, and individually these free electrons, they will experience a force when this conductor is placed in a magnetic field. The direction of magnetic field and flow of current is perpendicular to each other, and they make an angle 90 degree between them. Now come to the diagram again. Now this is the conductor. The current is flowing from left to right of the conductor, and when current is flowing from left to right, the electron which get drifted by the magnetic field, they experience a force perpendicular to the magnetic field, perpendicular to the velocity, and they drifted from right to left. You have to see in that diagram, current, this is a current from this end to this end, and these are the electron, that is the electron, that is the electron, V is the drift velocity with which they are drifted, and this is the component Fm. Fm is the magnetic component of force due to individual electron. That is this component Fm due to that individual electron. And here you have seen F. F is the total force that is experienced by the conductor. So now to derive that total force experienced by a conductor when placed in a magnetic field, Lorentz. According to Lorentz, the magnetic force experienced by an individual electron in the conductor due to magnetic field is given by Q into cross product of drift velocity and magnetic field. Now this drift velocity and magnetic field, they are vector quantity. In term of magnitude, when we solve the cross product B cross B, then cross product again when we solve, that give us a vector. So in the magnitude form, that is solved by using sin theta. So now in the magnitude form, the Lorentz component of magnetic force due to individual electron is equal to Q VV sin of theta. And we already studied the velocity and the magnetic field, they are perpendicular. If V and V, velocity and magnetic field, they are perpendicular, then angle between them is 90 degree. We substitute here the value of theta, that is 90 degree, and sin 90 we know that is equal to a 1. So Lorentz component of magnetic force experienced by an electron, that is equal to Q B into V. This is equation number 1. This is the Lorentz component of magnetic force on an individual electron having charge Q placed in a magnetic field B. If the total number of electron in a conductor is capital N, then the total force experienced by the conductor when it is placed in a magnetic field B, Ft total, that is equal to total number of electron in the conductor multiplied by the force experienced by individual electron. We get this equation number 2. N, capital N, number of electron in the conductor, that is equal to number of electron per unit length multiplied by volume of the conductor. So now we know volume of the conductor, that is equal to area into length, and number of electron per unit length we already consider, that is small n. जो लेंथ में है कितने इलेक्ट्रॉन है n, अगर लेंथ में n है तो वॉल्यूम में कितने आगे, दैट इज टोटल n इज इक्वल टू द नंबर ऑफ इलेक्ट्रॉन पर यूनिट लेंथ मल्टीप्लाई बाय द वॉल्यूम एरिया इनटू लेंथ. So we get the value of number of electron. If we substitute that value in the equation number 2, we get the total force, that is equal to NAL multiplied by Fm. Fm is the Lorentz component of magnetic force experienced by an individual electron, and that is due to all the electron. So that is equal to NALQ B into B. By substituting the value of Fm, we derive it, that is Fm, the force experienced by the individual electron in equation number 1, that is Fm is equal to Q B into B. And we substitute that value, we get total force is NALQ B into B. We get the equation number 4. But we know that the current flowing through the conductor in terms of drift velocity of an electron I is equal to NAV into Q, where N number of electron per unit length, A is area of cross section, V is velocity, drift velocity, and Q is charge on an electron. So that is the relation between current and drift velocity. If we substitute the value of current in this equation number 4, then we get the total force experienced by the conductor, that is equal to I L into B, that is NABQ. Here in this equation number 4, NA, this is a L and this is a Q and B. So if we see the value of I, NABQ, NABQ, तो बचेगा क्या, L और B, और इनकी जगह हम क्या लिख देंगे, I. तो total force is ILB. This is the magnitude of the total force experienced by a conductor having length L placed in a region of magnetic field perpendicular to it. In vector form, the total force experienced by the conductor, that is Ft, is equal to IL cross B. That is, we take cross product. I is a scalar quantity, L is a vector. Why we take that L vector? Because the angle between this L and V, length and magnetic field, that is perpendicular. They are perpendicular to each other. 90-degree angle is there. And when we solve them, then we use sin theta, because again we get a vector. So this is a vector form of force experienced by a conductor when placed in a region of magnetic field. This is the required expression. Thank you.